Okay, so on this video, we'll look at some more examples of graphing logs, and try as many of them as you want on your own, and then come back and graph them, or check them with what I've graphed, or graph them as we go. So on that first one, or the next one here, part D, I know that x minus 2 is a shift to the right. And I know that, again, key features, when you do the log of 0, you get it does not exist. So that's when that vertical asymptote is going to be. So at x equals 2, which is 2 units to the right, I know that there's going to be a vertical asymptote. And now I should always do my reflections first, or if I'm going to translate, that means just that reflection is now a reflection over the new translated line. So, a negative natural log would look something like this, right? Because it's, I'm sorry, that's wrong, negative. A negative natural log would look something like this, right? But now that's the image we're going to translate to the right 1 unit, or actually 2 units. So then it's going to look something like this. We take a nice stretch along there. So this point right here is now 3, 0. And then our vertical asymptote at x equals 2. And then if we want to put on another point, we could say it's the point E plus 2. And then again, that plus 2 would cancel that 2. And then we get negative 1 as a value. And then we could also say here, E squared plus 2, and that would be negative 2 as our next value. Okay. Now, next question, kind of going with our theme of what we did in class today, factor out that negative, right? So make it the opposite of x minus 5, and that's inside our log. So this negative is the reflection I'm going to do first. So I'm going to move that to the, so I'm going to do that first before I move it to the right. So again, our normal log graph looks something like this. Reflect that over the y-axis, it's going to be this image. So that's the image I want to shift to the right 5 units. And so then whether so like you're thinking about that. So I know I have a vertical asymptote at x equals 5, because again, the log of 0, whatever you put in here to make that a 0 is the vertical asymptote. And then we already knew what our reflected image looked like. It's something like this and going in that direction. So there's our x-axis and there's our y-axis. It definitely goes through 4, 0, because when we can make this thing as a 1, right, the log of 1 is 0. And again, I'm just using the word log very liberally here because it's any base. And then log base 4 counts powers of 4. So like then the way to make this thing a 4 is maybe choosing x to be 1. So when x is 1, we're evaluating 5 minus 1 is 4, log base 4 of 4 is 1. Because like 4 to the first power, remember we're counting exponents, so 1, 1. And then I'd like to maybe make a 16 because that's 4 squared. Well, how does this become a 16? Choose negative 11. And then that would go up to 2. And if you wanted to get the next one, choose 6, like how do you create a 64, right? Then you're going all the way out to negative 59, because then you could say, well, that's 64, which is 4 cubed. Okay. So then this one here, again, common theme, factor out a negative. So I would say that's the opposite of natural log. And I would factor out the 2 as well, because when you do that, you can clearly see this translation is 5 units to the right. So, and the negative 2 has to do with a horizontal compression. And the key there, though, is not the 2 part as much as it's the negative part. So then when I sketch this graph, go to another color here, just to get the XY axes. X and Y. So then, again, both are negative. So our normal log graph, natural log shape looks something like this. If I reflect over the y-axis, we get this image. And then if I reflect that image over the x-axis, I'm going to get the image that my graph's going to be, which is this. So that blue one is the shape I'm looking for. I'm going to translate that to the right 5 units. So let me clear my graph here, just so I have a little bit of a clearer view screen here. Get those transformations out of the way. So I'm going to the right 5. I'm drawing that vertical asymptote because I already know the image that I'm looking for, which would be which would be coming from up here, hugging that asymptote, and then going out in that kind of stretched in the x direction. This is x equals 5. Now, we have to be sort of careful here because this 2 here compresses our graph. So when we try to think about, remember, natural log of 0 doesn't exist. So that's why we knew that there was a vertical asymptote at 5, because 5 is making that 0. But then remember, natural log of 1 would be 0. And normally it's just like 1 unit away. But this 2 sort of, compresses everything. So how does this thing become a 1? It has to only be, it becomes a 1 when you choose x to be 4.5, because 2 times 4.5 is 9. So it's actually halfway in between that. So sort of an awkward point, or to kind of look there, it's 4.5, 0. Would be our intercept, and then, you could label other points on it. I like on a quiz or a test, it gets kind of cumbersome to label points that deal with logs and all these transformations that deal with E. So for this one, I might just label that intercept there and know this general shape. And I'm fine with that. Someone asked the other day too, said, well, what if you just choose 1? Like if I chose 1 for my point, could you do that? I'm like, well, sure. But then it's 1 comma natural log of 8. Because like 10 minus 2 is 8. So that's fine too. So you either choose powers of E for your X, or you get natural logs for your Y values. And that's fine too. Like you choose 2. And then at 2, it would be the natural log of 6. So either way, you have exact answers that are represented by exponents or logs. Okay, and it looks like, well, maybe we'll do one more here, part G. So I do see a shift to the left 8. I see a shift down 2, and I see a translation, a reflection over the x-axis. So I'm going to do that one first. So there's my y-axis. Here's my x-axis. So normally, again, logs look something like this, right? So if I reflect that image, the new image, that'll be the image of our actual graph, is this. So that green one is the image. So I'm going to take that image and shift it to the left 8 and down 2. So I'm going to kind of keep track of that point. So if that goes to the left 8, it was 1, 0. So going to the left would now be -7, 0. And again, -7 makes that plus 8 a 1, and log of 1 is 0. And then I need to shift that down 2. So 1, 2. So that new point is going to be right there. The vertical asymptote at 0 will be shifted again to the left 8 units. So now that will be at -8. So the graph should look something, the graph should look something like this. You're hugging that asymptote, we get to that point, we sort of stretch that way. So this point right here, again, is -7, -2. And remember, this is log base 10. So let's try to think about creating 10s. Or powers of 10. When does that equal 10? When x is 2. So when x is 2, I get log base 10 of 10, which is 1. Make it negative, and then subtract 2 more. So that's -3. Like 1 unit down from -2. Oh, there's a bell. And if I wanted to go out farther, think of a 100. What can I pick here for a 100? That's 92, right? So it's very far. And then that's 100, but that's 10 squared. So then you get your -2 minus 2. So that would be 92, -4. So again, thinking about that stretch along the x-axis. Okay, so hopefully that made sense. And if not, go back, double check, relook at them, and then pop in for any questions. But I'm hoping some of this does also look familiar a little bit from last year's study on logs.